In this video, I would like to explain how to use Policy Studio with that Git-based project to illustrate how policy deployment and everything based on that Kubernetes cluster running in the background can be used. For that purpose, I would like to use that Healthcheck API, which is constantly pinged by the load balancers. And this is by default returning just the message status OK. And I would like to show to you how this is handled by policies in the background by opening and changing that policy in Policy Studio. Once you have cloned that repository, you find a folder API or gateway config, and inside that folder there's a folder API manager, which represents what we call a group. And inside that there's a fat folder. I will make a copy of that path to make it easier now to import that API, that project into my freshly installed Policy Studio. And here you have three options. And in order to open that project, you just say open project, and then you pick the location where this project is. And you see this is the project API manager. And now you can open it, and it takes a moment until Policy Studio loads that. And then we will see how that Healthcheck API, which is executed over here, is handled, why there is a status message OK, and how we can change that. So, and the Policy Studio not only maintains the policies itself, which are in here, it also maintains listeners because each API gateway can have a number of listeners. And the default service where the health check is located is on this path. And here we say if a request comes in on that health check API, on that health check path, then a certain policy will be executed. This is what we call a native policy. And now I can have a look into that policy and see what it does, how it behaves, how it looks like, and how we can change the message within. So the policy itself has what we call two filters. All of the filters are here on the right-hand side. And each policy is running with a given context, and that context is based on, let's say, on what it is bound. In our case, the context is the health check for HTTP, and of course you can have multiple contexts when an API is used, when a policy is used for different things maybe. And then the context is injecting a number of attributes and so on. In our case, the given context is not so super interesting. It's more that we can see we are creating context because we are calling a filter that is called setMessage, and this one is creating a new context information content body. And then we are using reflect, and that is using the given content body and some HTTP headers, which are given automatically by the incoming request. And then we are reflecting that information back to the client. So, and if I look into the set message filter, I can see that the status message is okay, and okay, and then we say I'm healthy. Let's say it like so. So finish that. So now we do not need to deploy anything. It's not possible anyway. As we have modified something now in Policy Studio, it automatically became an outgoing change. So that means we can now push that change to the GitHub repository. I'm on the main branch. Normally you would do that on a feature branch, and then that feature branch or whatever would maybe deploy that configuration change to an integration stage or whatever. So let's say changed the health check. Health check policy. So the load balancer will be still happy with that, as the status code is still the same, which is, by the way, configured here in the reflect to return the status code 200. And now, as before, and as always, an integration workflow runs on our fork I'm working on. Which will create a new image, and that image is then automatically rolled out to the Kubernetes cluster running in the background, or operating that API management platform. So the image is now created, or is now going to be created. Then we push the image, and then we tell the Kubernetes cluster to deploy it. So let's have a look for the Kubernetes cluster. I'm saying get pods. Okay. All this goes very fast as the base image is used, and we are only adding a small additional layer on top of the base image. So now the API manager and the traffic these two pods are using that image, which makes sense. And now it's going to be initialized. So let's wait until the traffic is healthy. So it might be healthy already in the background, but maybe the Healthcheck has a too long delay configured here for my Kubernetes cluster. So now the new traffic is running, it is healthy, and it's going to terminate the other pods. So, and that's why we should now see health checks behaving differently by saying, "Hi, okay, I'm healthy." And this way, we have just modified a policy, and due to the automated DevOps pipeline, it has been integrated without any downtime, obviously, due to the rolling updates on the API management platform. That's all I wanted to show in this video, and thanks for watching.